Everybody. Today, we're going to be talking about Linux file permissions. So, Nate,
Everybody's favorite topic.
that's right. Well, I mean, if you can't access it, you can't use it. So,
Yeah, right.
let's,
It's exciting,
jump,
exciting stuff.
yeah, let's jump right into the terminal. All right. So, I think how people discover they have a permissions error is generally similar, right? Like here we are. I have this script that I've written, so I'm going to go ahead and execute it. Oh no! Permission denied.
Oh no! But you're like you made the thing, right? And it's your file. Why on earth would you not be able to run it?
Well, I don't know. Why don't we look at the permissions and how do we do that, Nate?
So there's this handy little command which we probably covered in that marathon episode where we did 100 commands called ls, which lists the directory structure. But there's a special -l which will show all the fun little metadata, not all, a lot of the fun little metadata about your file.
Yeah, and after the
Yes, you
transition,
could cat it. That's right, Rick.
uh, after the transition, we'll go a little bit more into what this is showing us. But essentially, that first string on the line, the dash rw dash r dash dash r dash dash, that's the permissions that have been assigned to this file, and
Yeah.
we are lacking a permission that would allow me to run this command. What permission are we lacking, Nate?
The permission is let me run this file, right? Executable. We need it to be executable.
Yes, we need it to be executable. All right, so we're going to use a command called, some people call it chmod. I call it
Chmod.
chmod.
It's chmod.
Yeah, chmod.
Most people
I
are
heard that one
wrong.
too. I'm going to chmod this file, which is a command to change the mode of this file.
Right.
And I'm going to use an expression to explicitly dictate what I want the permissions to be. So I want the user permissions on this file to be read, write, and execute. I want the group permissions to be read and execute. And I want the other permissions to be read and execute. All right, and now when we do our long listing, we can see that the permissions I have set are the ones that are assigned. Now, everybody has this X field in their permissions, right? That's the executable permission. And so now when I run my command again, right, it runs the script, right? We can see the script execute and the output from the script.
But your script is wrong. It lies.
We will do our best. We don't always achieve it, but we try. All right. So chmod is our critical path command, and ls-l, right? ls-l to inspect the permissions, chmod to change the mode of a file, and then you express how you would like that mode to be updated.
Yeah, I mean, how can you talk about file permissions without starting with chmod? So great.
Right. But there's a lot of other ways that we can describe what the mode is. I assumed that you knew what permissions you needed and what the permissions to do. So after we transition, we will go ahead and take a closer look at each individual permission, different ways that we can set and assign permissions, and go from there.
I
So
heard a
don't forget
rumor
to
that there
bash
might
that.
be a. Sorry, I heard a rumor there might be a whiteboard involved.
The infamous whiteboard. Yes. So don't forget to mash that like and subscribe so that we can continue making this content and you can be notified when we're going live. If you know somebody that would appreciate this content too, why don't you share it to them? All right. So after the break or after the transition, we will go back in and look at these permissions, describe what the individual permissions do, and then we'll look at different ways to set permissions. See you on the other side. Nate, I notice you have something different about your face.
Is it my nose? Did I forget to? Yeah, well,
Okay.
with Summit coming up, I decided to go a little flamboyant with the beard. So I hope everybody likes it.
Um, so let me re-swizzle my screen share a little bit. And Nate, why are permissions important?
Oh, I mean, there are so many reasons that permissions are important, but it really boils down to who gets access to what and who can run what, right? So you could have a file that they can read and write to, but they can't execute, which is great. You can have a file that someone can read but not write. You could even have files that they could say, write to but not read, which is a very weird use case. But there are some times where, like maybe you want like a quote unquote Dropbox directory where you can throw files into, but other people can't read it, right? So there's all kinds of crazy stuff you can do with permissions.
Right. And just as a reminder, I see Rick is already in the chat, but now's the time where those of you who are watching live can interact with us in the chat. If you are
Yeah.
watching deferred, please feel free to leave us a question or statement in the comments, and we will get back to you. All right. So why don't we take a look at the whiteboard here? And I'm just going to represent that first string that we saw on our long listing output, right? And on my original file, it looks something like this. And then there was a little bit of extra data um, for the rest of the line. But I think the two important things are this and that. So there was some other stuff in between the permissions and the
Yep.
ownerships
Date
of
and
this
time
file.
data and yeah, things like that. File size. I forget which columns go where, but yes.
Number of links, like that. Yeah, there's
Yeah.
other metadata, but these are the things for permissions that we care about. And so first, let me do a little bit more wizardry here. This thing right here, that's actually not a permission. That's the file type indicator. So a
Hmm.
dash means a
Right.
regular file. You also see things like a D because it's a
Hmm.
directory, or an L because it's a symbolic link. You may see C's and B's, which talk about character or block devices. So file type is the first character. And then there's these others, which I've unfortunately written over. Let me do this. Here we go. Um, the permissions are actually three separate fields that apply to three separate sets of people. All right, so Nate, who's the first field of three permissions apply to?
The first field would be the owner of the or the user, I should say, which would better fit the formatting you did in the critical path user, the user that owns the file. And if you jump over to where it says RHEL and wheel, that would be RHEL. RHEL is the user in this particular circumstance, this file.
Right. So when someone creates a file, by default, they're the owner of that file, and that's reflected in this field of the long listing permissions. And that first set of three permissions, that applies to how they interact with the file, right? So, and
Yep.
we'll get back to what those permissions are in just a second. What about the second group of permissions, Nate? Who do they apply to?
The second group would be the group. And in this case, that's wheel, right? On this file, that would be listed as wheel. But this is, the group ownership or the group, group ownership of the file.
All right. So the second set of permissions, they apply to the group that owns the file. And actually, very specifically, made sure that the group owner on my file was Wheel before the show started. What would we typically see as the group owner if we weren't messing around with file ownerships?
Generally, it would be the default group of the user, right? Which in most cases would be a group that is also named the same name as the user. But in some cases, if the user doesn't have their own group, if their default group is like users or something like that, it would be that, whatever their default group is.
Yeah. And so on Linux, we use a thing called user private group. So by default, when you add a user to Linux, A group is added for that person that shares their name, and they are a member of that group, and they're the only member of that group. That's not true of other Unix flavors. So other Unixes may have something like the staff group that everyone belongs to by default, or other stuff. But our users group was one that I used to see on Solaris, I think, if I remember
Hmm.
correctly. But normally, if you just create a file, it's going to be owned by you and your private group, which has the same name as you. And a little bit later, when we transition back into the terminal, I'll create a file. We'll see that.
And
All
as
right.
an administrator, right, you can set what I meant by default group is you can tell, even on a Linux machine, a RHEL box, you can set the user's default group to something other than that created group, which is what I meant, right? So you could choose to have a users or staff group and make that the default group for all of your users.
Yeah, but we start to get into some weird stuff when that happens. Like,
Yeah,
uh,
but you
so yeah,
can is the point.
it's true. It's true. You can do anything, Nate, because I believe in
Yeah.
you. But should you do anything? All right. The third field. So we got the user owner, the group owner. What's this third field? Who does that apply to?
The third field would be others, or also known as everybody else. This is sort of
Other.
like the world permissions.
Yeah, yeah, and those are really great misnomers that I hear used all the time for this field. So I've also heard everyone or world.
Yep, all y'all.
It's
Eric says it's all y'all.
uh, but it's not really everyone or the world, because it turns out these three sets of people are mutually exclusive, meaning you can only be in one of these categories. And so when someone is interacting with a file, the first thing we check is that user interacting with the file the user owner of the file? If so, they get the user permissions that are on the file.
Right.
But if they're not the user owner, then we'll check further. Are they in the group that owns the file? And if so, then they'll get the group permissions that are on the file. But only if they're neither the user nor in the group that owns the file will they be covered under the others field of the permissions.
Right.
So one of the things I saw when I was younger that made me laugh very heartily. I saw somebody once set the permissions like this on a file. Oops. Uh, uh, uh.
Hmm.
And they were very confused that things weren't working the way they expect. And I was like, well, that's because right here, you assigned yourself no permissions. So you can't interact with the file because there's no permissions that allow you to interact with the file. And they went, no, 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 no. You don't know what you're talking about, because see
But
over
everyone
here,
has it. Yeah.
everyone has access, right? Everyone. It's not everyone, because it's not you and it's not your group. So it's everybody else.
Well, you might have noticed that I said everybody else when I said
I did.
others.
Yeah. I did see that. I did notice
Not
that. And then you said
everyone. I
everyone.
did say world, which you're right is not true.
Yeah. So that's that's something to watch out for. All right. So we have the who do the permissions belong to, and each set is a set of 3. And if a permission is turned off, it's represented by a dash, right? That it's
Hmm.
not present. And so the permissions are always in the same order: the read permission, the write permission, and the execute permission. And so when they're all on, you see something like this guy, right?
Yep.
RWX. If they're only partially on, like right here, man, that was a terrible arrow. Um,
Arrows are
that
hard.
read and write, but not execute. And like right here, that's read, but not write and not execute. Okay. And you can see that when they're all turned off, like this guy right there, all
That's
dashes.
nothing. Yeah.
Yeah. All right. So let me open up a new sketch. That didn't work well at all. It unshared my screen.
It did.
Let's try this one more time. Okay.
There we go.
So we have the 3 people that permissions apply to. But there's also 3 different permissions, and we talked about them a little bit. Nate, what are the 3 different permissions?
3 different permissions are read, write, and execute. Or are you talking groups? Yeah.
Ooh,
That's an enormous pen you got there.
It is. It is. Let's try this. Okay, read, write, and execute. All right, so they mean different things when they're put on a file. So, Nate, if we had read permission on a file, what kinds of things could we do to it?
You could view its contents. You can open it in an editor, but you won't be able to change it. You could use cat to see what's inside of it. That might be about it. What am I missing?
No,
You can
that's
read it.
right. You get to look at its contents. You get to
Yeah.
access its contents. So you can use things like cat, less, view, which is the read-only version of VI. You could use it as an input file to something because that process could also, running as you,
Yep.
be able to look at the contents of the file. All right, so write permission. What does write permission get you on a file?
Well, it lets you change the file. You could also do things like delete it at that point too. So you can make changes to it in general.
Getting a little wishy-washy there. So write on a file lets you change the contents of the file.
Yeah.
You can add stuff to it. You can delete stuff from the file's contents. But write on a file does not determine whether you can add or delete it. Like you can't delete a file because you have write permission on the file. Because file permissions don't give the ability to remove files from a system. It's the directory that chooses whether you can add a file or delete a file from the system.
Oh yeah. Okay. Well, I stand corrected.
Yeah, so we'll here, let me
Directories are a special beast.
yeah, and in fact, execute permission on a directory does something completely different than how
Yes.
file. All right.
Who's ever been bitten by that?
So write permission on a file that you modify the contents of the data in the file, right? So now what kinds of things can you do to that file? What kinds of commands would you run and abilities would you have if you have write permission on a file, Nate?
I'm sorry, I was reading chat. What was the question you asked?
Uh, so if you have write permission on a file,
Yeah.
what kinds of commands would you run and what kind of capability would you have?
Oh, I mean, you can write into it. You could like redirect output into the file. You could open it in an editor and make changes. Um, you can delete from the file. So, delete lines or characters or whatever.
Yeah.
That about covers it.
Yeah.
But
So
not apparently delete the file. Sorry.
right. So the big thing is like you could use something like an editor and manipulate, either add or delete the contents of the file and save the changes.
Yep.
You can also use things like file redirects to change the contents of what's stored in this file. All right, execute. That's the one we used in the critical path. What's that give you on a file?
Well, execute does exactly what it sounds like. It lets you execute the file. So if the file is, see, this is where it's tricky, right? If it's just a plain old text file and doesn't have anything in it that could execute, then making it executable technically makes it executable, but it won't do anything, right? So if it's a shell script, like you used in the example, then a shell script, if it doesn't have execute, you can't run the shell script. But if it does, you will be able to run the shell script.
Yeah, so it lets you run this file as a command, right, or as an
Right.
executable on the system.
Which there's a whole new level of complexity as to whether it will actually execute, even if it's executable. all depending on the contents and what's in there, whether it's a shell script or a Python thing or a Perl script or something. Everybody's favorite language is Perl, right?
Indeed. So I'm just jotting down some notes here, what we were just talking about. So if you have read, you can look at the contents. Write, you can change the contents. Execute, you can execute the contents, which is like running as a command. And that's how files work. All right, but then we have the other thing.
Rick likes Perl too. Thank you, Rick.
Okay, so the same three permissions apply to directory type files too, but they mean slightly different things. So if you have read permission on a directory, meaning you can look at its contents, what kinds of things can you do, Nate?
You could do things like get a directory listing out of it.
Yeah. All right, so you could run like ls to list the contents.
Right.
All right, now this is the one that we were arguing about earlier, write on a
I wouldn't
directory.
say arguing, more like getting corrected on. Write lets you create or delete files within the directory.
Correct. So write permission on a directory lets you add or remove files from the directory, right? Because you're actually changing the contents of the directory,
Right.
right? And then the weird one is execute.
Yeah. So execute lets you enter the directory, right? Or can you read the contents of the directory if it's not executable? I think is the thing I'm unsure of at this point.
So kind of. So for execute, it's still called execute, but I'm going to change how I describe what that means. So for
Yeah.
file, it meant that you got to execute the contents like running a command.
Right.
But for execute on a directory, that lets you access the contents of the directory.
Right.
So in order to access the contents of a directory, what might you do? What command might you run?
I mean, just change directory. CD into the directory.
CD, changing the
Yeah.
directory into this directory provides you or you're accessing it, right? And so
Right.
without execute permission on the directory, if you try to CD into it, it would fail.
Yeah.
The other thing is that a directory file is really a list of the files that reside within it and their file pointer IDs. And so when we do things like add or delete a file with a write permission, you're adding a listing and a file ID and removing a listing and a file ID. But without execute permission, right, without access to the directory, things like long listings don't work. Because a long listing doesn't just look at the files that reside in the directory, it actually accesses that file pointer to retrieve extended metadata about the file, like its owner and permissions and number of links and timestamps. And without access to the directory, you are unable to actually retrieve that metadata from the file pointer. And so with read permission, you could do an ls just plain and get a list of file names. But if you
Okay.
try to do anything that would access the directory's file metadata, that will fail without execute because you're not able to actually look up the files and access them in order to get access to their data. All right. So that's a little bit about what the permissions are and what they mean. All right. So real quick, let's
Yeah,
see.
if you've ever tried to like recursively remove execute from a directory structure, you'll run into this, right? Because if you don't specify directories versus files, you'll end up taking execute away from all the subdirectories, and then all the subdirectories don't work anymore. Ask me how I know.
How do you know?
I've been there. I've been there. Try to do the right thing. Take execute away from everything because you know it's something that shouldn't have anything executable. All of a sudden, all the directories don't work anymore.
All right. So I was just resetting my screen share a little bit here because the next thing we need to talk about is how we changed the permissions. So earlier today, we said, oops, we looked at our file and it looked like this. And it was owned by RHEL and wheel. All right. And in the critical path, I used the chmod command to change the mode of this file, add execute permission to each of these people. And I used an explicit permission set.
Right.
I did a chmod and I passed u equals rwx, g equals rx, and o equals rx. But we could have also passed an expression to chmod to use the permissions that already exist to just kind of manipulate them a little bit.
Right.
And Nate, before the show, you're talking about I think you called it additive or subtractive method.
That's the word I've always used. I don't know if there's an official term for it, but yes, you can, in the format you're using there, if instead of putting RWX for user, you just did plus X, then it would add execute and keep whatever permissions else otherwise were already there.
Yeah.
And
So
then you wouldn't even have to define G and O because you're not changing those. Well, I
so
guess if you're adding execute to group and ownership, you could also do it that way.
yeah. So to do the same change, we could have said u plus x, comma g plus x, comma o plus x,
Or even
or
more simply, just plus X.
well, that
What do you
doesn't
mean? Well,
always work the way one you would expect.
it adds it to all three, which is what you're trying to do.
It doesn't always add it to all three. It usually does. It usually does.
Okay.
Like, there's things like umask and some other system settings that can change what that means. So I would say we could do a plus x. That's all people gain execute permission. And if you're reading the interwebs, most people think this would also work plus x. And like 99.9% of the time, it works.
Yeah.
Unless it's that 0.1%, in which case it doesn't, and it's super frustrating.
I've never seen it not work. I don't even know what the edge case is you're talking about.
Well, I've seen it. It's happened. All right. So we could have used any of these arguments as the argument for our chmod command, and it would have made the permissions change to this: rwx, r-x, r-x.
And
All right.
we said additive or subtractive, and we didn't cover subtractive. If you change that plus to a minus, it takes away that permission. So if you wanted to take away right, for example, you'd use u-w, right? So just to fully cover that.
So if you did a u minus w, it would do like
Yeah.
this.
Right. Right.
Yep. All right. But there's another way that we can change the mode of a file, Nate.
And I think Shantanu just asked that question in the chat. The numeric or octal method. Is that what you're leading into?
That's what I'm leading into.
But
So
there's math involved in this. So
there is. And so I wrote up the RWX up there in the corner for a reason.
yeah.
Because it turns out each one of these permissions is worth a certain amount of points.
Right. Right. And it's not as simple as you might think. So what is it? 1, 2, and 4 off the top of my head?
Yes, but which is which?
R is 1, W is 2, X is 4.
Are you sure about that, Nate?
Isn't it?
It is not.
What?
It is
Did I have
not.
it backwards?
You have it backwards.
I have it backwards. X is 1, W is 2, R is 4. It's the
Okay,
order you had them on the list there.
that's right.
That threw me off.
So the other way,
XWR, that's right. I had this memorized, and being on the live stream just made it drop out of my memory. I learned this
it's
30 years ago.
it's the pressure. It's the pressure of
It's the
being
pressure.
on.
Pressure.
All right. So each one of these is worth points. And so if I was to show you a file like this, no idea why we would set the permissions this way. They look silly and crazy. It's
It's
only
just to
for
make
us
me
math.
it's just to make me do math on screen is why you did it this
That's
way.
right. All right. So this, I'll help you out here. This is the user
Yeah.
permissions. How many points of user permissions do we have?
So the way you do this is you add them up, right? So R is worth 4, X is worth 1, so it's 5.
Okay, how
W, of
much?
course, is only worth 2. And then RW would be 6. So
And
if you've ever seen permissions that are like 644, right? That means RW for the user, RW for the user, and then read for all the other, for group and the others, everybody else, all y'alls.
right. And so what we would do if we wanted to use this method, the octal method, or numeric method is the other way to
Yeah.
describe it. Right? We would do a chmod 526 file name that we want to change the permissions to, right? And it will ignore what was there before. So unlike the additive or subtracted method, it doesn't care what the permissions used to be. It will assign them to be RX, write only for group,
Yep.
read for others. So remember my funny example where the person set the permissions to be this? And they said, oh, everybody has everything. So they ran a chmod.
Yep.
And how many points do they give the owner of the file?
So it's that famous spy from Britain, right? 0, 0, and 7.
Yes, that's 0, 0, 7. So that's how you do octal permissions. And so some really common ones to see are 664, like Nate said, right? So 664.
Or 755 if you include execute.
All right. So if we're going to represent these in symbolic notation, we would say for 664 something like RW, RW, R dash dash. Right.
Mhm.
6 points for the user, 6 points for the group, read only for others. And for this one, 755 is really common on what kind of file, Nate?
Just anything that's executable, something that's executable by everybody,
Yeah. And so
like
like,
something in bin, something like that.
yeah, so scripts, commands, they're
Yeah.
executable. There's another type of file that's almost always executable.
Directories.
Yeah. So it would be something like this: RWX, R dash X, R dash X. Right. So read, write, execute for the owner, that's the 7 points of value. Read plus execute, that's 5. And read plus execute is 5 for others. All right. So I think we're ready to jump back into the terminal.
You can actually do some of this now.
just real quick, producer Eric is already angry that I promised to be on time and then clearly have failed to be on time.
No, you promised to try to be on time.
Oh, that's true. I did
It
try.
was a valiant effort.
All right. So here we go. Here's file 1. So if we were looking at file 1 and we wanted to add the write permission to the group that owns the file, right? The RHEL group.
You
What would,
could
yep.
chmod g plus w it, or you could chmod, and this is the thing where it gets tricky, right? You have to account for the other permissions that are there if you're going to use the numeric method that we did before, right? So unless you want to change user, you have to calculate in your head what's RW, which of course we said is 6. And then RW for the group would also change to 6. So you do 6, 6. And then the R for the everybody else, of course, would have just been what, 4, right? So
Right. So we can say G plus W that says take what exists today and just
and
add
add
it
this.
to group, right? That would
Yep.
work. And then if we want to do the octal method, we'd say, okay, we want, when we're done changing the mode of the file, we want the user to have read and write permissions. So that's 6 points. We want the group to have read and write permissions, which is 6 points. And we want others to retain their read permission, which is 4 points.
Right.
So there we go. All right. So there's my test directory. Nate, let's just monkey around a little bit and remove execute permissions from all people on test directory.
Okay. So you do or you want all people, like including the owner? Well,
Everybody.
you could just do, well, I mean, we'll fall into your edge case here, but if you just did -x, that's what I would do. But you could do U-X, G-X, and O-X.
Yeah. Or you could say A minus X. Or we could use the octal mode and say, after this change was made, I want it to be 644. And there we go. So now if I
Right.
at tester, right, I put a file in there. Whoop, doesn't work, kind of.
Can't even look.
Because we have,
Oh, no, yeah, all right. Permission denied, but then shows you the file. Yeah.
all right. So if you run the ls command natively, it'll work. But as soon as you try to access those additional things, like the permissions and stuff,
It's like, I don't know. I can't get to it. Get the
yeah,
file, though.
we don't have permissions to look up that file metadata.
Right.
All right. And if we try to CD into it,
Permission
nope, can't do
denied.
that. You don't have access, right? That
Which
execute
is,
permission access.
like so many errors on Linux, is so misleading. Yes, technically permission denied, but if you look at permissions, you're like, but I have permission. Why?
Because you have to know that you don't have permission because you don't have the
Exactly. Exactly. This would probably lead, like, you would think permissions are fine, and then it would lead you down like an SE Linux rabbit hole. Then you'd be like, why doesn't it work?
All right. So I put the execution back on there, and we can CD into tester. All right. And see, because I'm the owner of this directory, I get write permission. Right. So I can do things like create files. But if I remove that permission, whoops, helps if I use the right stuff.
You want you, yeah.
Okay, so if I try to remove tester new file, not allowed because I don't have write permissions on the
So
directory. However,
you have you have ownership of the file in there, don't you? You still can't delete it just because even though you've got ownership of it, right?
correct.
Right.
Whoops, I meant to redirect that.
Just driving home my correction from earlier. Thanks.
Right, so I can still manipulate the contents right? Because the new file has write permission. That means me allowed to change what's in it. But because I lack the directory right, I can't delete it or add new files, right? If I try to create a new one. Right? Nope, can't do it. Can't create new files. All right.
So there's some
Interesting.
discussion in chat about whether root overrides that directory no longer executable problem.
Okay, so a couple of weird things about permissions. First, and I think you just noted this, Nate, as the owner of the file, you have the ability to add or delete permissions.
Right.
Even though we remove the permission for ourselves to access the directory or to write files to the directory, because we own the directory, we're the listed owner of that directory, we can always add the permissions back again.
Right.
So even in my weird case where the guy did user 0 permissions, group 0 permissions,
He was
everyone
still able
else,
to put it back. Right.
he will put it back because he's the owner of the file.
But so say everybody no longer has execute to a directory. Can root still cd into it? Can root still ls-l it?
So root, because they are the super user, the administrator of the system, ignores file permissions
Right.
and has the ability to set permissions on files they do not own.
Right.
And so if you don't own the file, generally you're not allowed to mess around with its properties like its permissions. But root is the exception to that. As the administrative user, root can change the permissions on a file. They can also access things that the permissions don't explicitly give them access to. So let's say that root actually, here, let's look here. Let me become root. All right, so here we are. Root, not the owner of the tester, not the
Right.
group owner tester, and yet can create a file in tester, right? According to our description earlier, they would have been considered an other, which does not have write. In fact, nobody has write
Right.
permissions on store right now, except because they're root and therefore special, they are able to ignore it.
So what if you chmod -x, a-x tester? Could root still cd into the directory? Is I think the crux of what I'm trying to ask here.
All right, so this is what you want. There's no
Right.
execute tester.
Right. Does it give execute back to root? Yes, it does. Okay.
Because root, we look at the context of what root is doing, like
Right.
CDing.
Right.
And whatever root is trying to do, they will be permitted to do because they're root,
Right.
independent of what file permissions exist.
But execute on a file permission or execute for root is different on a file. Because if the
Right.
file's not executable, root still can't execute it unless they make it executable.
Correct. So,
right. So it's weird, right? Things get weird. There's no absolutes here.
All right. So I removed the execute permission from
right.
the new shell script, right? And if
Right.
I try to run it, all right, we also get a permission. However,
Shantanu wants to know what happens if you chmod -x user bin chmod.
well,
because the
so
episode hasn't gone on long enough.
who owns the chmod command? Root owns the chmod command, which means that
Yeah.
root can add or delete permissions as they see fit because they're the owner of the file. So
but how would root add the permission back if chmod itself was not executable? I think is the question.
well, I might be going into rescue mode to fix it.
Yeah, right. Don't do
All
that.
right.
How's that sound?
Cool. That's kind of all I wanted to cover today. I know that there are a couple questions in the chat, Shantanu, about the extra numbers that one may see on permissions, on numeric mode permissions. And we're actually going to be covering those next week when we talk about special permissions which is SUID, SGID, sticky. And we will also be covering file system ACLs next week. So some
And then
extra.
everyone's head's going to explode. ACLs, they always the
So
whole like
the
masking stuff and yeah.
yeah, the masking stuff gets crazy town, but like if you keep it
Yeah.
simple,
Right.
it's all right. Use the KISS principle, Nate. Keep it simple, silly.
Yeah. Yeah. Well, I'll save my story for next time when we're actually talking about ACLs, but I have ACL stories.
ACL lessons learned.
Yeah. Yeah.
All right. Were there any other questions I didn't answer? Because I know that I was kind of rolling today.
Not that I saw. I don't know if Eric copied any down that producer Eric, sorry. Nope. Sounds like we're good.
Cool. So next week, into the terminal, more permissions, but the special ones, right? So
The
set
special ones.
UID, set GID, and STVX, also known as sticky permission. And then we'll also cover a little bit on file ACLs, which is a way
So
that
what
you
about
can.
umask? We should probably talk about umask too. Or did you say that?
On the upside guide, Nate.
Well, we're gonna add it.
All right. We'll see if we can fit in umask too.
Yeah.
Umask is something that sets the default file permissions that people
Yeah.
get when they create files or directories.
Also known as user mask.
Yeah. And then coming up is Summit, so we're going to be off for a week after that.
Yep.
To accommodate people recovering from their week-long, I guess, Red Hat adventure of Summit.
I'll be on an airplane, I think.
So after next week, we'll have a couple weeks, maybe a week or two off, and then we'll return. But any parting words on permissions, Nate?
Don't chmod -x user bin chmod.
If you can, you'll just be learning rescue mode probably sooner than you
Yeah.
wanted to.
Yeah.
All right, because like what did I just say? Like you could do anything you want.
Yeah,
I
right. I
believe
have faith in you.
Should you do those things? Oh, that's another question entirely.
Right.
All
All
right,
right, folks.
everyone.
Thanks for joining us today.
Till next week. Happy into the terminaling.
Have a great one.